பாஸ்கர் இந்த ஏசி ஆன்ல இருக்கா? அது ஆன்ல இருக்கு. ஓகே. இதெல்லாம் க்ளோஸ் பண்ணி, டோர்ஸ்லாம் க்ளோஸ் பண்ணி. இருக்கா? கப்பை வாஷ் பண்ணணுமா? So here, how much is the net flux that is given? Yeah. So how much is the net flux that is given? 8 into 10 power 3 Newton meter square per coulomb. So what is the net charge? You're right. So charge enclosed is equal to pi into epsilon naught. Okay. If the net outward flux through the surface of the box were 0, so this is an important point. If the net outward flux through the box were 0, can you conclude that there were no charges present inside the box? Can we conclude that there were no charges that were present inside the box? Why? Because, yes. So total flux is equal to charge enclosed divided by epsilon naught. When I take the charge enclosed, if it comes out to be 0, this charge enclosed, sorry, what are they saying? If the net outward flux of the surface is 0, yes, accepted that the charge enclosed is 0. But what is happening? This is not the charge that is pertained due to one charge. It is a charge due to the system. It can be in such a way that there were equal amount of positive and equal amount of negative charges. So what is that we can say for this? We cannot conclude that there were no charges at all. Read the question carefully. They asked, can we conclude that there were no charges itself? No. There could have been charges in such a way that the total charge is going to be a 0. Right? So answer is no, we cannot conclude. And the reason being simple. Right? Right? Shall we proceed to the next one? So point charge plus 10 microcoulomb is placed at a distance of 5 centimeter above the center of a square of side 10 centimeter as shown in figure 1.34. Actually, the diagram is missing. So there is a square here, and at a distance of 5 centimeter from the square, there is a charge of how much value? 10 microcoulomb that is placed. Right. So the question is, what is the magnitude of electric flux through the square? So what we can do in this scenario is, since it's not completely forming a closed surface, we can imagine that this charge was placed inside a cube like this. Where this bottom side is what the square is. And this 5 centimeter is exactly the center of this cube. So what should be the length of this cube? The length of the cube should be 10 centimeters. So we need to consider a Gaussian surface whose shape is a cube of side 10 centimeter. Right? When you consider this kind of a situation, then what is going to be the flux through this square? So what is the flux through the cube? So what is going to be the flux through the cube? Flux through the cube is going to be charge enclosed divided by epsilon naught. So which is going to be 10 microcoulomb divided by 8.85 into 10 power minus 12. Am I right? So this is the flux through the cube. But what is the question? They didn't ask through the cube. They asked through the square. So flux through the square will be 1/6 of the flux through the cube, because it consists of 6, right? So it is going to be 1/6 into the charge enclosed divided by epsilon naught, right? So here you need to substitute the values and then find out the answer. You're not able to see? Done. Shall we proceed? So look at the next question. A point charge of 2 microcoulomb is at the center of a cubic Gaussian surface, 9 centimeter on edge. What is the net electric flux through the surface? It's very simple. So charge is how much? 2 into 10 power minus 6 coulomb. It's placed at the center of the Gaussian surface, right? And the edge is given as 9 centimeter. The question is about flux. It's very simple. So what is the value of flux? Flux is equal to charge enclosed divided by epsilon naught. We are done with this. So this is an unwanted information, right? So charge enclosed is 2 into 10 power minus 6 divided by epsilon naught is 8.85 into 10 power minus 12. Clear? Okay. Next. An electric charge causes an electric flux of minus 1 into 10 power minus 10 power 3 Newton meter square per coulomb to pass through a spherical Gaussian surface of 10 centimeter radius centered on the charge. So there is a Gaussian surface which is centered on the charge, and the flux is how much? Minus 1 into 10 power 3 Newton meter square per coulomb. So whenever the flux is negative, right, remember that the electric field lines are entering the surface. So when can electric field lines enter the surface? Only when the charge is negative. Only then it will be able to receive the field lines, right? So if you see the first part of the question, okay, one more thing. The radius is given as 10 centimeter, which is 10 into 10 power minus 2 meter, right? So if the radius of the Gaussian surface were doubled, how much flux would pass through the surface? What will be the answer? So R or R dash is equal to 2 times R. What will happen to the new flux is what the question is. What will the answer be? It will be the same. What is the reason for it? Because Yes, it is independent of radius. It is independent of radius. And what does it depend on? It depends only on the charge present within the system. So the charge present within the system is still going to be the same. So what is going to happen to the flux? It will not change. Next is, what is the value of the point charge? So flux will be equal to charge enclosed divided by epsilon naught. So which implies charge enclosed is going to be equal to flux is how much? 10 power 3 into epsilon naught is 8.85 into 10 power minus 12. So it will be 8.85 into 10 power minus 9 coulomb. That will be the answer. They asked what is the value. No, here I took only the magnitude. So you can just see it as a negative charge. I've already mentioned it. No? See at the back, have they given it as negative, then put a minus. It is understood. Or you can write it's a negative charge. See at the end of your statement, right, when you're reporting, you should mention somewhere that's, or you mention it at the beginning also, it's fine. Am I clear with this? Shall I proceed? Next. A conducting sphere of radius 10 centimeters has an unknown charge. If the electric field 20 centimeters from the center of the sphere, so electric field, okay, I'll take the radius to be capital R. Electric field at a distance R is 1.5 into 10 power 3 Newton per Coulomb, where the value of R is given as 20 centimeters. So 20 into 10 power minus 2 meter. Then, and it is pointing radially inward. Radially inward means again you have a negative charge, right? What is the net charge on the sphere? So we know that the electric field due to a conducting sphere is going to be 1 divided by 4 pi epsilon naught into Q divided by R square. We have derived this already, right? So it is going to be 9 into 10 power 9 into the value of charge is what we need to find, the whole divided by R square. R is how much? 20 into 10 power minus 2. So how much is that going to be? 400 into 10 power minus 4. And what is going to be the value of electric field here? It is 1.5 into 10 power 3. 1.5 will cancel this 6 times, right? So this will go 6 times. Q will be equal to, observe, 400 into 10 power minus 4 is 4 into 10 power minus 2, right? So 4 into 10 power minus 2 will go this side and get multiplied with 10 power 3. So what is that you're left out with? 40. So which implies Q is equal to, this side you will have 40, the whole divided by 6 into 10 power 9. Right. Can I write this as 4 by 6 into 10 power minus 8? Because this will go up as 10 power minus 9, multiply with this 10, 10 power minus 8. So 4 by 3 is going to be 2 by 3. Sorry, 4 by 6 is going to be 2 by 3. So 2 by 3 is 0.67 into 10 power minus 8. This is going to be the answer. This is the charge that is present on the sphere. Clear with this? Shall I proceed? Let me know once you're done. Done? So this one. A uniformly charged conducting sphere of 2.4 meter diameter. So diameter is 2.4 meter, has a surface charge density of 80 into 10 power minus coulomb per meter square. Okay. Find the charge on the sphere. It's very simple. Right. You know that sigma is equal to Q divided by A, which implies Q will be equal to sigma into A. So Q will be equal to, what is the value of sigma? It is 80 into 10 power minus 6 into, what is the value of A? It is going to be 4 pi r square. What is the value of r? When d is 2.4, r will be 1.2 meter. So Q will be equal to 80 into 10 power minus 6 into 4 pi multiplied with r square is 1.2 the whole square. Right? On solving this, you're going to get the value of the charge in coulomb. Right? So this is the charge on the sphere. Next is, what is the total electric flux leaving the surface of the sphere? So what is the flux that is leaving the surface of the sphere? Flux will be equal to the charge that is enclosed divided by epsilon naught. So what is the charge that is enclosed? You already have the value here. Take it from there and divide it with epsilon naught, which is 8.85 into 10 power minus 12. So these many Newton meter square per coulomb is going to be the required answer. Okay. Done? Done. The next one. An infinite line charge produces a field of 9 into 10 power 4 Newton per coulomb at a distance of 2 centimeter. So R is equal to 2 centimeter. Calculate the linear charge density. So if you have a linear charge distribution due to this at a distance R, right, at a point P, what is going to be the value of electric field? It is given as lambda divided by 2 pi epsilon naught times R, right? So electric field is equal to lambda divided by 2 pi epsilon naught R. So how to solve this is multiply and divide it with 2. So that this will become 4 pi epsilon naught. And we already know the value of 1 by 4 pi epsilon naught. How much is it? So this 2 is there into 1 divided by this 4 pi epsilon naught is going to give you 9 into 10 power 9 into lambda is what we need to find. the whole divided by R, which is 2 into 10 power minus 2. So 2 and 2 will get cancelled. So what is, and the value of electric field is also given, which is 9 into 10 power 4. So 9 and 9 will get cancelled. 10 power 4 will cancel this like this. So lambda will be equal to 10 power minus 2 divided by 10 power 5, which is going to be 10 power minus 7 coulomb per meter. So answer will be 10 power minus 7 coulomb per. Is that clear? If you are clear? Here. You're done copying, no? So 24th one. There are two large and thin metal plates which are parallel and close to each other. On their inner faces, the plates have surface charge densities of opposite signs and magnitude of, how much is it? How much is this value? How much? 17 into 10 power minus 22. So it is 17 into 10 power minus 22. Okay. Now, see, let's read the question again. Two large thin metal plates are parallel and close to each other. So when they say large, here they are considering it to be of infinite length. So basically, it is a infinite length plane sheet. So there are two plane sheets like that. So this is one and this is another one, which are placed close to each other. And how are the charge densities on each? They have opposite signs. So here, if you have plus sigma, here you have minus sigma. Am I clear with this? Right. And the magnitude of surface charge density on each. If I take only the value of sigma, it is going to be 17 into 10 power minus 22 coulomb per meter square. Right, coulomb per meter square. Then what is going to be the value of electric field in the outer region of the first plate? Okay. Suppose I say the positive charge is like this. The negative is like this. Right. Due to the positive charge, what is going to be the direction of electric field? Rightward. So this is the direction of electric field due to the positive charge. What is the direction of electric field due to the negative charge? It is towards itself. Am I clear with this? Right. This side, what is going to be the direction of electric field due to the positive charge? It will be like this. Because due to the positive charge on the other side, imagine my hand to be the plate. Due to the positive charge here, it was to the right. Due to the positive charge here, it is to the left. Right. But due to this negative charge, what is going to be the direction of electric field at this region? It will be in the rightward direction. Am I clear with this? Similarly, due to this positive charge, what will be the direction of electric field here? To the right, because it's away from it. It is E plus. And due to the negative charge present here, the electric field is to the left. Am I right? So, due to an infinite plane sheet, we know the fact that the electric field is going to be sigma divided by 2 epsilon naught due to one side. So all the values of E that I've written is sigma by 2 epsilon naught, not sigma by epsilon naught. Understand this? Am I clear with this? Right. Having said this, what will happen is, if I call this as region 1, for instance, if I call this as region 2, and if I call this as region 3. Now, what is going to be the value of electric field in the outer region of the first plate? Outer region of the first plate is to the left. So electric field in region 1 is going to be the vector sum of these two. So which is going to be sigma by 2 epsilon naught due to the positive charge in the leftward direction, right? And another sigma by 2 epsilon naught due to the negative charge in the rightward direction. Are they not opposite to each other in terms of direction? See, this is the magnitude. But since I've already drawn the arrow marks there, if I take the direction into consideration, for the positive charge, I'm giving a minus sign. Don't get confused. I'm not giving minus sign because of the negative charge density. No, I'm giving this minus sign because of the direction. Leftward, I'm considering it to be negative. Rightward, I'm considering it to be positive. So that is what I'll do throughout the problem. Okay. So this is negative. This is positive. So what will happen? It will get nullified. Answer is 0. Similarly, what is the electric field in the outer region of the second plate? Meaning in the region 3 is what they are asking. Electric field in region 3 is how much? Due to the positive charge, it is sigma by 2 epsilon naught plus due to the negative charge, it is minus sigma by 2 epsilon naught. Why? Directions. Right word is positive, left word is negative. So what will happen? Here also it is 0. So what about the electric field between the plates? That is in region number 2. So it is going to be sigma by epsilon naught due to the positive charge plus sigma by epsilon naught due to, sigma by 2 epsilon naught due to the next positive charge. It will get added. So answer will be sigma by epsilon naught in the rightward direction. And this is a very, very, very important expression to be remembered, because in the next chapter, we'll be discussing something called as parallel plate capacitor. At that point, we'll use this expression. Actually, this problem is a lead to that concept. I hope I'm clear, right? I think this is what you asked me on the other day, why they are taking the directions. Now you got clarity. Right? So I hope everyone is clear, right? Tell me one thing, is everyone clear with how to take directions going forward? Will you be able to do it on your own? Right? So make a note of it. Netra, clear? Which one? This one. See, this plate is there. Both the sides positive charges. So due to the positive charge present on the palm, what will be the direction of electric field? Away. That is what this is. And what about this? It is due to the positive charge that is present here, left. So this electric field due to the positive charge is taken due to the first plate. Okay, this point is clear. Forget it. Okay, you have already drawn it. Forget it. Now this plate is there. There is negative charge here, negative charge. Due to this negative charge, what will be the direction of electric field at this point? Will it be, so forget that this plate is existing. What will happen? Is it towards or away? Towards. That is why I drew this. So what is happening in the case of an infinite plane sheet is the magnitude is a constant. You remember the graph also, it will be parallel to the x-axis. So that is the reason why they are getting nullified. Okay, so they get cancelled out. So to put it very simple, in this kind of an arrangement, in the outer region there is no electric field. The electric field will exist only within the region or between the plates. What about this one? You tell me, no. Due to this charge, what will be the direction of electric field at this point? Forget that this is existing. That's why I drew it away. No, forget this. The negative plate is there. Negative charge is there. What will be it will be towards? Yes, ma'am. Where did they cancel? Answer எப்படி வந்து ஞாபகம் இல்லையா? இல்ல புரியலையா? Answer match ஆகுதுல? Okay, you wouldn't understand. Did you complete call? Okay, I didn't see that point. Actually, I thought it's there outside also. But anyways, we covered another point also on their inner faces. Yeah, but this is how it works. So you show. This is 10 power 4, right? Where is it? Ah, 10 power 4, இது 10 power 9. If it goes to the others, or இதுவும் cancel பண்றேன்னு வச்சுக்கோ. Imagine this goes to the other side. 10 power 9 by 10 power 4 என்னது? A power m by A power n. 10 power 5 இல்ல? அதான் அந்த 10 power 5. So 10 power 5 போட்டு what I did is lambda the side I left it. I actually did 2 steps. அதனால we confused you. 10 power 5 போட்டு I took it to the other side. That's why it came as 10 power 5. Understood? Clear with this? See, there are some more problems which are important. I'll explain. Which I think the 12th and the 13th one, I didn't explain them. 12, 13, and 14 also I'll do it. You have the question here, no need to it. Solution. Shall I proceed? So look at the 12th question. Yeah, this one. Okay, I'll do the 11th also. Vaishnav, you're there? Yeah, this question is for you. Yeah, see. See, what is the charge here? 3 into 10 power minus 7, 11th. What is the charge? Okay. So listen. There is a polythene piece which is rubbed with wool and is found to have a negative charge of 3 into 10 power minus 7 coulomb. Estimate the number of electrons transferred, and they're asking from which material to which material have the electrons got transferred. So what is happening? You have two materials. What are they? One is a polythene and the other is a wool. Right? When these two substances are up against each other, due to friction, there is a transfer of charge. And who's gaining the negative charge? The polythene is gaining a negative charge. So the charge on the polythene is how much? 3 into 10 power minus 7 coulomb. So they're asking how many electrons have actually got transferred. So how to apply it? Number of electrons, if at all you see that Q is equal to N into E. So it is going to be 3 into 10 power 7 is equal to the number of electrons multiplied of the electron is 1.6 into 10 power minus 19 coulomb. Right? If I approximate it, this to 1.5 or this to 3.2, I can say this will cancel this 2 times. So how much is it going to be? 2 into 10 power 7, and this 10 power minus 19 will come to the other side as 10 power minus 19, but numerator it goes as 10 power 19. So answer will be 2 into 10 power 26. So these are the number of electrons that have got transferred. But the question is, who has gained these electrons? It's polyethylene. So they asked from which to which. No, electrons have got transferred from wool to polyethylene. I hope that makes sense. They have got transferred from wool to polyethylene. -7 are them. Okay, -7 means then it should be. So 10 power 19, it should be 10 power 12. So 2 into 10 power 12 are the number of electrons that have got transferred. Yeah, this is -7. No, sorry. Okay. Now this is the one you asked me on the other day. Is there a transfer of mass from wool to polyethylene? The answer is yes. Why? Because electrons mass is also taken into consideration. Here we are not talking about the atomic mass, right? When you speak about it, one of the materials is losing electrons and the other one is gaining electrons. Yes, there is a transfer of mass. So here what is happening? Wool is losing its mass and polyethylene is gaining its mass. So there is a transfer of mass that is taking place. It is because we take the mass of the electron into consideration. Because they told no, found to have a negative charge. Polythene piece rubbed with wool is found to have a negative charge. Polythene is, so that's the subject, no, first one. Actual question, you should have had a punctuation like this. A polythene rubbed with wool, comma, is found to have a negative charge. Yeah. I hope now you got some idea of how the mass concept works, right? Shall I proceed? Yeah. Can you have the last page open? I need some value. The answer sheet. Shall I proceed? Yeah. See, look at this one. This is actually a simple problem. Based on this, we have the next one. Are you copying? Are you done? Done. Okay. So two insulated charged copper spheres. So the reason why they have used the word insulated is because the material is charged, right? It is not losing any of its charge to the surrounding. That is the meaning. If at all you see this kind of a question in case-based question, they might ask you what is the meaning of that insulator. So where will you use that? Because you should not get confused, no? Insulated charged copper, now you should not think of it like a conductor and then get confused. Okay. So any conductor can be charged, but it can be insulated from the surrounding. Why do we do that? So that because conductor can lose its charge easily to the surroundings. You need to keep it protected. Okay. So two insulated charged copper spheres, A and B, have their centers separated by a distance of 50 centimeters. So you have two spheres whose centers are separated by a distance of 50 centimeter. What is the mutual force of electrostatic repulsion? They have mentioned it as repulsion. So obviously they both have like charges, right? So 6.5 into 10 power minus 7, and this is going to be another 6.5 into 10 power minus 7. Both are in terms of Coulomb. The radii of A and B are negligible compared to the distance of separation. When they say this, right, it means you're dealing with point charges. Whenever you deal with point charges, you can think of Coulomb's law. So F is equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by R square. So this is going to be 9 into 10 power 9 into Q1 into Q2 is how much? 6.5 into 10 power minus 7 into 6.5 into 10 power minus 7, the whole divided by, what is the value of R square? So it is 2500 into 10 power minus 4, right? So when you solve this, what is the answer? You will get somewhere around 1.5 into something. 1.5 into 10 power minus 3. 10 power minus 2. 1.5 into 10 power minus 2 Newton. This part I'm leaving it to you. So this is going to be the value of electrostatic repulsion that is existing between. Am I clear with this? Right. Now, they have asked another question. What is the force of repulsion if each sphere is charged double the above amount and the distance between them is half. Right? Meaning, if I take this to be R, if I take this to be Q and this to be Q. So what is the new scenario? There are two charges of 2Q and 2Q and the distance of separation between them is R by 2. So what is going to be the new force? Observe, F dash will be equal to 1 divided by 4 pi epsilon naught, right? Into 2Q into 2Q is going to give me 4Q square, the whole divided by R by 2, the whole square is going to give me R square by 4. Am I clear with this? See, Q is the initial charge. Here, Q1 into Q, observe 1 by 4 pi epsilon naught into Q1 into Q2 is basically Q square divided by R square. Okay. Now, this is the new scenario, F dash. So, observe, can I write this as 16 times 1 by 4 pi epsilon naught into Q square divided by R square? This 4 will go to the numerator. So, it becomes 16. I took that 16 outside, everything else is written. But what is this value? This value was the initial force that happened, that was exerted, right? So it is going to be 16 times F. You already know the value of F, which is 1.5 into 10 power minus 2. Substitute it there, you're done. Okay. This is going to be 16 into 1.5 is 3 by 2 basically. So 16 into 1.5 into 10 power minus 2. It will give me 24 into 10 power minus 2 Newton. Right. 16 into 3 by 2, 8 into 3, correct. Yeah. It's going to give me 24 into 10 power minus 2 Newton. Am I clear with this? This is not the toughest part. Let me complete the next one and then you can copy it. So the next question is connected to this. Right. Here, what they are saying is, suppose the spheres A and B in exercise 1.12, that is the previous problem, have identical sizes, and a third sphere of the same size but uncharged, right? It is uncharged and it is brought in contact with the first, and then what is done? And then it is taken in contact with the second, right? And then finally removed from both. After doing this, they're asking what is the new force of repulsion between the charges A and B. So let's observe. So this should be compared to the scenario of the first case, not the second case. So here you have charge Q, here you have charge Q, and the distance of separation between them is R. So what is happening? You have this charge A and this one as B. You have an uncharged sphere C, which is obviously not having any charge. When C is brought in contact with the first, then what will happen is there will be a redistribution of charge taking place. The redistribution of charge will take place in such a way that the new charge on A is not going to be Q anymore. Rather, it will be Q plus Q is the initial charge of A. 0 is the initial charge of C. Q plus 0 divided by 2, which will be Q by 2. Right. So Q by 2 is on A as well as C, so that the total charge of the system is still the same. Am I clear with this? No. This C, now it is having Q by 2. This Q by 2 is taken in contact with this Q. So how much will be the new charge now? It will be Q plus the whole divided by 2. So it is going to give me 3Q by 4. This 3Q by 4 is going to be present here. And the distance of separation is still R. So if I call this force as F double dash, right, this is going to be 1 divided by 4 pi epsilon naught into the product of these two charges, which is going to be Q by 2 into 3Q by 4. So the numerator is 3Q square and the denominator is 2 into 4, which is 8, the whole divided by R square. So what I'll do is I'll take this 3 by 8 outside. Then this will be equal to 3 by 8 times 1 divided by 4 pi epsilon naught into Q square divided by R square. If you observe, this 3 by 8 into this value is the initial force. Now the value of the new force is going to be 3 by 8 times the original force. So what will be the answer? F double dash will be equal to 3 by 8 into 1.5 into 10 power minus 2 Newton. Clear with this, right? So this is how it works. Right here we speak about the redistribution of charge. So make a note of this. So I'll show you the previous slide. We're done with this slide. And make a note of this also. Clear? Shall I proceed? Okay. So one last problem. You're still copying. Done. Okay. So one last problem. See, the diagram is not given. I think this is positive, right? So this is negative. And I think one will go like this and the other will go like this. And the third one will go like this, right? First, second, and third, right? So if you see, figure 1.33 shows tracks of three charged particles in the presence of uniform electrostatic field. Give the signs of these three charges. It's very simple, right? So what is going to be the sign of the first charge? It is going to be negative because it's getting attracted towards the positive plate. This one is also negative and this one is going to be positive. It's a very simple question. The second part is, which particle has the highest charge to mass ratio? So charge to mass ratio is Q divided by M. And the answer to this is, it is that particle which experiences maximum deviation. And the reason to this is, if you remember the problem that we solved yesterday, y is equal to QEL square divided by 2m into Bx square. We got this, right? The 33rd problem, right? This y speaks about the deviation the particle has traveled, and this Q by m is the charge by mass ratio that they are asking. Am I clear with this? So they both are directly proportional. Hence, how to find the value here is, in your book, what you can do is take a pencil, just keep a scale parallel to this, right? From here, extend it like this. Extend it in this way, and take this angle to be θ1, this to be θ2, and this to be θ3. Whichever is greater, that will be the answer. Try that and tell me what is the answer. So go to the question, just take a scale, use a pencil, extend the horizontal path. So extend the horizontal path. So which one is the answer? Which one is experiencing more deviation? So what is the answer according to you? 3 is right. You can see that 3 is bending the most, right? It has the greatest charge by mass ratio. See, actually, you need not know this, right? Because we solved the problem yesterday, I just connected this. What we can say is, the particle which experiences maximum deviation with respect to its initial path will have greatest charge by mass ratio. I hope it's clear, no? So with this, we are done with the NCERT problems. Also, additional exercise is not needed for CBSE. So as I mentioned, next week you will have a test. Next Saturday. What is the date? See, listen to this. 21st of April. 21st of April, you will have a test in this chapter. It will be for 40 marks, not 35. Your main paper is for 70 marks only. But I have already prepared a 40-mark paper, but the time given will be only 1.5 hours. So prepare accordingly and come. It will be exactly as the board pattern which was proposed last year. We'll have MCQs, assertion reason-based questions, subjective, and then case-based questions. In case-based questions, you will not have options. Subjective, okay, exact pattern. So prepare and come. And if you have any doubts, you can reach out to me. Is it clear? So any other doubt? All are clear? Time it will be from 5 to 6:30. It's the same time, it's fixed. You either have it on Saturdays or Sundays. Sundays na morning 10:30 to 12. Next Saturday, man. Next Saturday. Okay. And make sure that everybody should come here and write the test. Okay. So that's it from my side. You can come only post. Munadi varam there. Okay. So we'll wind up. And one more thing. See, Monday I'm not there actually. Monday I'm not there. I have some travel plan. So Monday, what I'll do is I'll give you the basics of the next chapter. As I told you, go through the pre-recordings and then come. Maybe around 4 to 5 videos. It's already, I don't think I've uploaded. It will be there in a section called as pre-recorded. Are you guys going through the videos, watching whenever you have doubt? Have you opened it, right? So videos, now you have the first chapter, right? Similarly, I'll be adding another folder called as pre-recorded. In the pre-recorded, you will have chapter 1 and chapter 2 videos on. Okay. In the chapter 2, I'll give you it will be exactly in the order. Lecture 1, this is the topic. Lecture 2, this is the topic. You just need to go through and make a note of it. So like that, I'll give you whatever is needed for at least 35 to 40 minutes. So you need to work only for 40 minutes to make those notes. Okay. So work accordingly and then. When? So you need to write after that. Okay. So shall we wind up? I asked you to draw a horizontal. Extend this horizontal line, whichever is experiencing more deviation. See, that's what everyone did. Show it to her. She did it. More deviation. Third one is experiencing more. No? That's the answer. Yeah. Okay, guys. I'll see you all on Tuesday, 18th. Okay.